So this is my latest project, home-built gas chromatograph. Let's see now, let's sample injected into the instrument. And let's see, we should see some peaks. The sample injected is a propane-butane fuel mix, and it also has some air. That's the air you see there as an unretained peak. And yeah, the other peak should come shortly. This is a project I decided to do after researching and figuring out that nobody else is doing this, or very few at least. And yeah, it's just a home-built gas chromatograph. That's what I'm doing. That is of course not what you'd call a commercial grade quality chromatogram, but considering it's done on 3 feet of column packed with cat litter, I think that's okay. So let me just take you through the instrument. This is the carrier gas. This is just a commercial balloon helium, which then are run into this pressure flow controller that gives me seamless regulating, stepless regulation from 0 to 80 psi, I think. And that then runs through the reference side of my detector and into the inlet. The inlet is just a T-fitting with a rubber disc called a septum, and that then runs into the oven through these bulkhead connectors. This is the column. This is what does the actual separation, and it's packed with crushed bentonite clay from cat litter, 80 to 100 mesh. That is the very old-fashioned way of doing gas chromatography, simply having a packed column of some kind of adsorbent. It could also be alumina or silica. Slightly later they started to coat it with different things, that I'm going to try that too. In fact, I've tried both Vaseline and candle wax. Both works okay. The column then exits through the detector side of the thermal conductivity detector, and this is just 4 elements again of these T-fittings, and in the third port here, the side port, a little instrument light bulb, which is also 1/8 inch in diameter, that's been ground open, is sitting as an element, and that's then heated, and then it reacts to the thermal conductivity difference between the carrier and the outlet of the detector. That is then run to this differential amplifier, where I reference it to a stable DC source, in this case just a battery. That's not a very elegant solution, but it does work, right now at least. I can then set the 0 point of the detector and set the gain. I've then run that over to an Arduino Uno board that just locks that, and just plot that in Microsoft Excel, and that works fairly well. There are of course many things that could be optimized in this. Most people who's used a gas chromatograph will notice that it's not heated, and that's pretty much a non-starter for 99.9% of the compounds you want to run chromatography on, or gas chromatography on at least. And I'm going to do that, but I just wanted to explore the concept before doing that, because making a temperature regulated oven is an engineering problem, not a separation science project, and I wanted to see if it actually worked before investing the time into doing that. I will do it, of course, at some point. Yeah, but it actually does work, and as you see, the baseline is keeping fairly steady. But yeah, so that's the project, and it works for now. I might do some more videos on more details on the different components and how I constructed them and what I want to do in the future. Maybe maybe explore some more of the details of the theory behind it.